Friends, we were dealing with the basis of reaction. We know that the electrophiles and nucleophiles interact with each other and they form the chemical bonding and it gives rise to a new product and the process is the reaction. The chemical reactions occurs due to the interaction of electrophiles and nucleophiles. Today's subject of discussion is chemical reaction. We can define chemical reaction as a process in which the chemical transformation occurs to one of the set of chemical substances to another. The chemical substance gets transferred from one to another. This transformation includes change in the energy. That is, the energy can be either released or absorbed in the form of heat. If it is released, then it is an exothermic reaction. If it is absorbed, it is an endothermic reaction. This change in energy can be sensed in the form of color change, in the form of production of gas, or in the form of temperature shift. As I told, exothermic, endothermic reactions. In this process, the atoms are conserved. If the starting material and the reactant has 10 atoms, the same 10 atoms will be there in the final product too. But it has changed its positions and it has rearranged itself. This is law of conservation. The atoms in the starting material and in the products will be same. It says that the mass can neither be created nor be destroyed. We cannot create anything as human being from nothing. Only thing is we can convert from one form to another form. Overall, the chemical reaction can be defined as follows. It is a process where the substrate, which is also called as starting material, reacts with reactant to transform into a new product or new substance which are called as products. By rearranging their atoms and breaking or forming the chemical bonds accompanied with the change in the energy in presence or absence of catalyst, reagent or solvent, which results in change in their chemical identity unlike a physical change. The product identity, chemical identity may be different from the starting material. The alcohols can be converted into acids. The acids can be converted into alcohols. The identity of the product, chemical identity, has completely changed. The product which is formed may have complete different chemical identity than that of the starting material. When a definition is asked, you have to define chemical reaction as a process where substrate reacts with the reactant and transform into a new substance called as products by rearranging their atoms and breaking and forming chemical bonds with change in energy in presence or absence of catalyst, reagent or solvent, resulting in change in their chemical identity. Here I can give you an example. Methane reacts with 1 mole of methane react with 2 moles of oxygen, or 1 molecule of methane reacts with 2 molecules of oxygen. When it is heated strongly, it gets converted into carbon dioxide and water. Here, the number of carbons present in the starting material is 1. In the product also we have 1 carbon. The number of hydrogens present is 4 in the starting material. Here also we have 2H2, 4 hydrogens in the form of water. The oxygen, 2 molecules of oxygen, that is 4 oxygen atoms. Here 2 oxygen atoms, here also 2 oxygen atoms. Overall, there is conservation of atoms. The methane is an alkane, whereas these are carbon dioxide and water are not completely organic compounds. They have changed their chemical identity. And in the process, we have used a solvent or reagent or catalyst. Here, the bond between carbon and hydrogen is broken, and the new bond between carbon and oxygen is formed. Hydrogen, which has been broken, has combined with oxygen, and this is how the reaction occurs to give rise to a new product. The substrate, that is the methane, reacts with the reactant, that is oxygen, in the presence or absence of catalyst, reagent or solvent to give the products, that is carbon dioxide and water. In this process, there is change in the energy and it results in a new compound with completely different chemical identity. Now you can appreciate the role of chemical reaction to get the new products by using the various reactions and making the substrate to react the reactants, we get new products. This is how we prepare new compounds, new set of compounds with completely different chemical identity. The chemical reactions involves the change in the position of electrons while forming or breaking the chemical bond between the atoms. Here, when there is a breakage of bond or forming of bond, the position of electrons are shifted in between the two atoms. As we have seen in methane, carbon hydrogen bond has broken and carbon oxygen bond has been formed and oxygen and hydrogen bond has been formed. In between the atoms, there is a breaking and forming of bonds and there is the shifting of electrons or the change in the position of electrons. It's only the electrons which are involved in the chemical reaction. The nuclei is not involved. And this change in the electrons position and formation of chemical bonds and breaking of bonds can be described by a chemical equation. There is no involvement of nuclei. The electrons, especially present in the outermost orbitals, which are called as valence electrons, are responsible for the chemical reaction. The nuclei is not involved. As you know that atom is made of protons, neutrons and electrons. Protons and neutrons forms the together the nucleus and the electrons revolve around the nucleus across a particular area called as orbital and electrons are arranged based on the different energy levels of the orbital. The outermost orbitals, the electrons which are present are called as valence electrons and these valence electrons are involved in the chemical bonding or bond breaking. There is the position of electrons change. Nuclei is not involved. If at all nucleus is involved, that is called as nuclear chemistry. It is the subdiscipline in the chemistry In this nuclear chemistry, it involves chemical reactions of unstable and radioactive elements where both electronic and nuclear changes occurs. In general, all the reaction in non-nuclear chemistry, only the electrons are involved. There are various types of chemical reactions. These chemical reactions can be classified into six types based on what type of reaction it occurs. The first type of chemical reaction is substitution reaction. One atom is substituted by another atom. One group is substituted by other group. It is something like I am working in an organization, and if I am not working properly, I will be substituted by the other. The substitution reaction, this is called as substitution reaction, or it is also called as displacement reaction. One group is displaced by the other. This substitution can occur either one nucleophile can be substituted by other nucleophile, one electrophile can be substituted by other electrophile, then it is called as electrophilic substitution. One nucleophile is substituted by another nucleophile, it is nucleophilic substitution. Or one free radical can be substituted by another free radical, then it is free radical substitution. There can be three types of substitution: nucleophilic, electrophilic, and free radical substitution. Another one is type of reaction which we come across in organic chemistry is addition reaction. The addition occurs if I am not strong enough in an organization, I will be substituted. If I am very strong, I cannot be substituted. Then it can, the organization can add up few than substituting me. The addition may be by nucleophile or electrophile or free radical. Accordingly, it can be nucleophilic addition, electrophilic addition, or free radical addition. This third type of reaction we come across in chemical reaction is elimination reaction. It can be, examples I can give is dehydration, dehydrohalogenation. That can be alpha elimination, beta elimination. Elimination occurs like hydrogen from one carbon, halogen from another carbon, which are adjacent to each other. Then if it is eliminated, then it is called as dehydrohalogenation. If the hydrogen from the first carbon and the OH group from the second carbon is eliminated, H plus and OH minus combine together to lose as water molecule, and that's why water molecule is removed. That's why it is called as dehydration reaction. Dehydration is a type of elimination. Dehydrohalogenation is also a type of elimination. Dehalogenation reaction, dibromoalkane, 1,2-dibromoalkane. If I remove two bromine groups which are adjacent, present on adjacent carbon, it is dehalogenation. These all are types of elimination reaction. If it is having two substances, one is the substrate, another is the reactant, it can undergo substitution, addition, or elimination reaction. If it cannot undergo reaction, it can rearrange itself. That is called as rearrangement reaction. What is this rearrangement reaction? Generally, rearrangement reaction occurs within the molecule. This is shifting of the groups within the molecule to give a rearranged product. A primary alcohol can get converted into a secondary alcohol by rearranging the position of the OH group within the same molecule. We will be studying about these reactions in detail in the different compounds. Other than this, four reactions: substitution, addition, elimination, and rearrangement. Another thing is oxidation. Oxidation, as the name indicates, addition of oxygen or removal of hydrogens. Reduction. It is reverse of oxidation, that is addition of hydrogen and removal of oxygen. The whole chemistry, there are only five types of reaction: substitution, addition, elimination, and rearrangement, followed by oxidation reduction. If one molecule get oxidized, another molecule gets reduced. An oxidizing agent reacts with a reducing agent. In the process, the reducing agent get oxidized and oxidizing agent gets reduced. That's why it is called they go hand in hand. That's why it is given as oxidation reduction reactions. The whole of the chemistry, there are only five types of reactions: substitution, addition, elimination, rearrangement, and oxidation reduction reaction. We are applying the same five types of reactions to different molecules to get the different products. All the reactions, what we do is the five reactions only. But for different starting materials or substrate, different reaction conditions are required for substitution, addition, elimination, and so on and so forth. That should be monitored and that should be standardized. The reactions, the organic chemistry is very simple when we understand these reactions very well. In the process of reaction, we have seen that there is bond dissociation and bond association. The bond dissociation can be of two types. One type is heterolytic cleavage or heterolytic fission. In heterolytic cleavage, the bond breaks with unequal sharing of electrons. When the bond breaks, the electrons, when the bond is formed, electrons are shared between the atoms to give the molecule. Why atoms share the electrons? To become more stable. Atoms are less stable, they share their electrons and to make it to become more stable. When they break in the reaction, the breakage occurs at some point and formation occurs at some point. This bond breakage is bond dissociation. It can be heterolytic cleavage. In heterolytic cleavage, dissociation occurs with unequal sharing of electrons. As there is unequal sharing of electrons, that is more energy required, energy intensive. I take Rx, an alkyl halide. The X is being the more electronegative atom. It has, what is electronegativity? The tendency of the atom to keep its electron with itself. More the electronegative is, more it keeps with itself. It do not share its electrons with others so easily. When the bond is found between R and X, there is unequal sharing of electrons. That's why the halogen will become electron rich and the carbon becomes electron deficient. This gives rise to polar bonds. When they divide, when they break, the X takes its electrons with it. When it takes away the electrons, the R becomes electron deficient and X minus X becomes electron rich. This is heterolytic cleavage. There is unequal sharing of electrons during the division. It is something like two brothers when they share their property. One take away the higher amount of property, another will become deficient. Living groups, this heterolytic cleavage occurs when living group moves away with the electron pair. When this living group moves away with electron pair, an intermediate is formed that is transient in nature. Transient means is highly unstable. And this unstable intermediate is called as carbocations. Carbocations are the intermediate formed. It is unstable because it is having lesser amount of electrons. When my brother takes away a more amount of property from me, I'll become deficient. When I am deficient, I become transient. And I will try to earn that by doing something else. This reaction, hydrolytic cleavage or fission, occurs either in liquid phase or in the presence of polar solvent. And in the presence of polar solvent, ions, the plus and minus, are stabilized by the polar ions of the solvent. Or when an organometallic compounds are there like alkyl lithium, when it breaks, lithium itself is electron rich, and that excess electrons it leaves to R, and it moves away without electrons. And when it moves away without electrons, it becomes electron deficient, and R becomes electron rich. Both the cases it can occur. Here in Rx, the brother is negative in nature. That's why he takes away the electrons with him. Electrons is like money for compounds. Like money is for human beings, electrons is for molecules or organic compounds. And when there is breakage, there is unequal sharing of electrons. This brother X is electron negative. He takes away the electrons, making his co-brother a electron deficient species. Here another brother, lithium, he is more passionate towards his brother. He gives away its electrons to him and he will go away. Then the brother is electron rich. This occurs when living group moves away without electron pair. The heterotic cleavage can occur in either of the case. In organometallic compounds, this type of reaction occurs where the living group moves away without electron pair, giving an electron rich intermediate. This transient intermediate, which is electron rich, is called as carbene ion, carbon with excess electrons. That is something like nucleophile. In this case, carbon with less electrons. It is something like an electrophile. Carbocations and carbene ions are electrophiles or type of nucleophiles also. This also occurs in liquid phase or in the polar solvents. When this is how it occurs. Another type of dissociation is homolytic cleavage, or it is also called as homolytic fission. Here, the dissociation, when the bond breaks, there is equal sharing of electrons. Dissociation of the bond with equal sharing of electrons. We call it as TTMM, tu tera me mera. Electrons are equally shared. Tu tera me mera. That's why there is no friction. Thus there is no friction, less energy. Whereas in heterolytic cleavage, it is energy intensive. Here it is not requiring that much of energy. It occurs when they are having like atoms or R. When it breaks, where one carbon takes its electrons, another group it takes its electrons, and equal sharing of electron occurs. It gives rise to free radicals as transient intermediates. These intermediates which are formed are highly unstable because it is not stable. Why? Means it is highly reactive. Why it is highly reactive? They are deficient. R plus or free radical. It is also electron deficient. This is also electron deficient. As they are electron deficient, they want to become more stable. How it can become stable? By interacting with other groups. R plus look into other nucleophiles. R minus look into other electrophiles to react so that it becomes stable. R is also unstable, though it has taken its share, but still it is unstable. That also reacts. These intermediates are formed in the course of the reaction. Either carbocations or carbanions or free radicals. This occurs due to heterolytic or homolytic cleavage. These intermediates are neither starting material nor product. They are in between stage. These intermediates combine with other opposite intermediates and they form the bonds and they become stable, and in the process products are formed. In the starting material, bonds are broken and this bit gives to intermediates, and these intermediates again combine with other groups in a different way and it becomes products. This is how the reaction occurs. Bond dissociation gives rise to intermediates, and these intermediates combine together to give bond association.